and RECTENNA for ESM applications. As an outline, our presentation is structured as follows. First of all, I'm going to give you some view about harvesting energy system. Then I'm going to give you some information about RECTENNA and their characteristics. After that, to evaluate the performance of our circuit, some study must be done. Then, at last, some concluded point must be taken. Like we see in this figure, the energy harvested market is witnessing continuous growth, where the market size reaching up to 706.92 in 2023. Then it expected to reach more than in 2033 to $1829.27 million. It means that there are people investing in order to harvest the energy. The question here, what mean by harvested energy and how we can harvest this energy? Harvested energy is the process to producing electrical energy by capturing the energy from the environment, from the renewable energy. This technique is very important in order to power the devices, because the lifetime of traditional battery is very limited and it's very toxic. This figure show the renewable energy. For example, solar energy using photovoltaic cells, magnetic vibration, and thermoelectric energy. Also, we have radio frequency energy. In our work, we are going to use radio frequency energy. This energy is it's variable in the environment with a huge amount because it comes from communication networks. For example, satellites, Wi-Fi satellites, or digital TV and others. Also, it is available or present with in all days and in all times. It's mean in all conditions. Also, with this technique, we can avoid RF pollution. It means we can avoid interference with electromagnetic waves. Also, the health of the people became more safety. The question now, the answer of the second question is how we can harvest this energy. The answer is this system is use RECTENNA device. The main goal of this device is to convert in RF radio frequency energy into DC voltage. Like figure 3 show, the RECTENNA system or RECTENNA device consists of 3 imported elements, receiving antenna which collect electromagnetic waves from the environment, and rectifier block based on a Schottky diode, and matching impedance placed between them to ensure the maximum transfer of the energy from the sources to the load. To evaluate the performance of this device, we must evaluate two quantities. The first one is DC voltage level, and the second one is RF-DC conversion efficiency. These two performance, or these two quantities are dependent on input power level and sensitive for the frequency change. It's mean when we have input power level, different input power, and when we have frequency change, here we have mismatching and increase or decrease in the efficiency. The proposed design of the RECTENNA system is presented in this slide. The main circuit consists of two sub-circuits. The first one here, and the second one is presented like this. The first sub-circuit is the impedance matching. This circuit consists of passive element, inductor and the capacitor. These two elements, the value of these two elements is tabled in the table 1. And the second circuit is the voltage doubler configuration based on a Schottky diode. Here we use HSMS 7630 model. Now we pass directly to see the results. We start with the input impedance. The input impedance is calculated using Z in simulator in ADS. This result is very important, like I told, that it is ensure the maximum transfer. And the second one, as mentioned, figure 6, as mentioned, our circuit is operated at 2.45 gigahertz. In this figure, or in this slide, the figure represents the efficiency of the proposed circuit versus the input power and the load resistance. As mentioned in figure 7, the efficiency has been increased between the range from -20 to 0 dBm, then decreased until 20 dBm. The peak value of the efficiency of our work or of our circuit is up to 17% at the 0 dBm and at 5 kilo ohm load resistance. And the figure 8 shows that the efficiency is increased rapidly, then decrease after some value of the resistance, and the optimal value of the peak value of the efficiency at the optimal value of the load resistance is up to 17%. Also, the simulated output voltage level of RECTENNA versus input power and load resistance are represented in this slide. It observed that the DC voltage increase with increases of the input power as well as the increase of the load resistance. An optimum output voltage is equal to 1.5 volt is achieved for a load resistance of 5 kilo ohm and input power equal to 0 dBm. As a conclusion, a single band RECTENNA has been presented and discussed using voltage doubler topology. The goal of our work was to design an effective single band RECTENNA operate at 2.45 gigahertz and dedicate for ISM applications. To achieve this goal, a study of RECTENNA circuit was conducted using an ADS simulator. Simulation result using ADS simulator showed that the proposed RECTENNA is capable to harvest energy at 2.45 gigahertz and has a potential application in ESM application. As perspective, this project can be improved by designing the same circuit for dual band or change in input conditions. It means we can change the load value or input value to increase the efficiency and to increase the output voltage. Here we have some references, and thank you for your attention. If there are any questions, I'm happy to answer. Thank you.
Okay, is any question? I ask Dorian to continue moderate.
Yes.
And I will continue. If you have, do you have some questions? Sorry. Okay.
No,
Not
no.
any question?
Still, I want to ask if you designed this antenna, but have you a practical device obtained based on this design?
I don't understand.
You design this antenna. Have you created the object of the antenna and experiment with this, or it's only a simulation?
Yes, it's only a simulation. I don't do the realization, RECTENNA realization, but I will did it and I will improve the result more.
Okay, thank you. Thank you.
Welcome.
The next question is from Sound Naomi Ionela. Analysis of operation of photovoltaic hybrid system, electric grid, diesel generator roof. Ionela, do you hear me?
Hello, yes.
Please start your presentation.
Yes. Do you see the screen?
No, you must share the screen. Click on a share button with a green arrow, and then select
Now?
the window of the presentation. Now it's okay.
Okay. Hello, my name is Franda Naumionela, and together with my colleagues, Elisabeta Spunei, Cristian Paul Chioncel, Gheorghe Ștefan Mătăsaru, and Florina Piroi, I developed the paper name Analysis of the Operation of a Photovoltaic Hybrid System, Electric Grid Diesel Generator Group. This work appeared as an identified need at the company where I work. 3 photovoltaic installations were installed at the company at different times and later connected to the grid. The company being at the end of a 220 kilovolt power line, there were many times interruptions in the power supply. These interruptions also put the photovoltaic systems out of operation, the inverters being of the on-grid type. As the company I work for manufacturers diesel generator sets, we designed and implemented a scheme to connect the diesel generator set and the photovoltaic system in parallel to ensure power supply when the grid voltage is missing. In this paper, the transient regime caused by switching from the diesel generator set to the grid and from the grid...
Sorry, can you hear me? Sorry to interrupt you. I don't see your presentation. If you want to button bit F5.
The presentation is viewed, but only the content of the presentation.
The roles, please. Okay.
It's okay now?
Yeah, yes,
Button.
it's okay. Yes.
Okay. In this paper, the transient
You don't
regime...
see you don't see against your presentation on your slide. Nu vedem prezentarea ta vis-a-vis de ce prezinți. Dă-i un F5 și la fiecare prezentare
Da, eu acum doar spun și...
Ok, nu, acum vrei tu. No, bine. No,
nu am foarte mult pe PowerPoint, doar...
ok, scuze.
Este doar PowerPoint-uri, am doar câteva puncte și vorbesc.
Scuză-mă, sorry.
It's okay.
Don't forget to change the slide. This is the conclusion.
Yes, it's okay. Where is the slide? In this paper, the transient regime caused by switching from the diesel generator set to the grid and from the grid to the diesel generator set with the photovoltaic system in parallel is analyzed. The paper is structured in 5 chapters where we present a short introduction, the hybrid solar grid diesel generator system installation, the measurement of the amount of electricity supplied by the photovoltaic system during 1 year from its application, the analysis... Sorry?
Yes, okay, go on.
Okay. The analysis of the transient regime of the hybrid system and conclusions. It is known that solar energy has long been used to produce electricity. Between 2010 and 2020, the cost of producing electricity from solar system fell by 82%, and Europe-wide, energy produced in photovoltaic system represent 5.5% of gross electricity production. The user's hybrid installation is supplied via a 3-phase transformer from the 20 kilovolt grid, and the customer is supplied via 3 circuits according to the scheme. On circuit 1, we feed the 60 kilowatt photovoltaic installation where is it located on a hall. We feed the customers in the test hall, painting hall 2, and office building 1. On circuit 2, where we also have the 25 kilowatts photovoltaic installation, we feed the customers in the laser hall, bending and welding hall, material sheet, and painting hall 1. On circuit 3, where we have the 40 kilowatt photovoltaic installation, we feed the customers in assembly hall 1, assembly hall 2, and office building. The diesel generator set of the hybrid plant has an output of 360 kilowatts, a speed of 1,500 RPM, supplies standardized single-phase and three-phase voltage at a frequency of 50 Hz and supporting a current of 587 amps, 200 kVA total installation power. The total installation power of the consumer is 236 kilowatts. To identify the amount of energy produced by the photovoltaic system and the chat taken from the grid, we used a dedicated application, which was available in February 2023, when the last 25 kilowatt photovoltaic system was commissioned. It should be noted that the photovoltaic systems were purchased only from the user's budget, as we had not previously carried out of a study dedicated to identifying its efficiency. In this table, we have shown the amount of monthly energy consumed from the grid, from the photovoltaic system, and feed into the grid. The analysis showed that during 1 year, the total energy consumption was 256.2 megawatt hour, and the amount of energy produced by photovoltaic system was 121.47 megawatt hour. This represents 42.21% of the user's consumptions. For the analysis of the hybrid system operation, we made the recording on 12:04 in the time interval 4 p.m. to 5 p.m. For the measurement, we use a network analyzer at the scenario analyzed was: the customer takes electricity from the diesel generator group to the photovoltaic system, synchronized with it. We reconnected the grid the moment that diesel generator set went out of operation and the inverters synchronized with the grid. A period followed where the consumers was taking power from the grid and the photovoltaic system. In this picture, we have shown the transient process analyzed, namely how the phase voltage vary. During the period when we took power from the generator and the photovoltaic system, there was a 5.98% increase in the voltage on phase B compared to the standard voltage of 230 volts. Analyzing the value average of a period of 10 minutes, the voltage on phase B had an increase of 5.04% compared to the standardized voltage. In this image, we have shown the variation of phase voltage in the transient mode caused by grid, reconnection and synchronization of the photovoltaic system with the grid. The duration of this regime was 2.3 seconds period in which it is found that for 0.05 and the voltage decreased to 0. This decrease deregulated the technological process, causing rejects of the process parts in the laser cutting machine or even failure at the equipment. When operating with the voltage taken from the photovoltaic system and from the grid, the phase voltage are very close to the standardized value. The highest value being 232.14 volts on phase A, i.e. an increase of 0.93%. In this image, during the transient process caused by the disappearance of the voltage from the grid and the startup of the generator or the synchronization of the photovoltaic system with it, it was found that no null value of the voltage appeared on the three phases. The duration of this transient regime was 1.6 seconds, and after synchronization, the voltage value per phase were within the maximum limit of 5%. In this picture, we have shown the variation of the current on the three phases during the period analyzed. The highest value of the current was identified on phase B with a value of 58.28 amps. At the same time, a roughly symmetrical loading of the three phases is observed with the current varying between 55.71 amps and 58.28 amps. In this picture, we have shown how the frequency varied over the period analyzed. It can be seen that the frequency was stable during the period when the customer was taking energy from the grid. During the period when the user was taking electricity from the photovoltaic system in parallel with the diesel generator, the frequency decreased to 49.923 Hertz, i.e. by 0.154% of the standard value. In conclusion, the behavior of the hybrid plant can't be estimated from simulation, but electrical measurement must be performed. Analyzing the amount of energy produced by the photovoltaic system, it was found that it represents 42.21% of the user's energy consumptions during the period analyzed. Considering the period quality, the average value of the phase voltage was 236.886 volts, i.e. 2.99% higher than the standard value when operating the photovoltaic system with the grid. When operating the photovoltaic system with the diesel generator set, the value of the phase B voltage does not meet the requirements of the standards, being 5.04% higher than the standardized value. The duration of the transient regime is quite short, but solutions need to be found to ensure continuity of supply. Thank you.
Thank you very much for your presentation. If there are any questions about it.
Hello, do you hear me?
Yes.
Yes.
I'm Emil Pejic from Serbia. I would like to ask you something. You mentioned that you have all diesel generator or photovoltaic system. Are you too far from the grid, or these two you consider these two options, or renewable energy resources or a generator? Where is the connection with the grid? Is that too far, or this is the special case?
Can you repeat the questions, please?
And the consumer is with special priority. When you lose some kind of energy, you switch on the generator. I think so. Because you mentioned
Yes.
possible variation of voltage and how to supply special consumer. But I mentioned, do you have a connection with the grid, or it's an island system where you have or generator or photovoltaic system?
Photovoltaic system.
Photovoltaic system. Okay, only that I want to ask. Thank you.
Thank you.
Thank you. Other question? If there are not, thank you. And the next question is from Marius Lolea. Data analysis and fuzzy logic modeling regarding electricity availability of photovoltaic panels. Please, Mr. Lolea, share your screen. We cannot hear you. Mr. Lolea, your sound.
Can you hear me? Sandra,
Yeah, now-
please open your
Yes,
presentation.
now we can hear you.
Okay.
Everybody hears me?
I can hear you.